Hello everyone. Today we will be looking into GATE Chemical Engineering question number 63 from GATE 2022. An elementary irreversible liquid phase reaction 2A gives B is carried out under isothermal conditions in a 1 meter cube ideal plug flow reactor or PFR as shown in the figure. The volumetric flow rate of fresh A nu1 is equal to 10 meter cube per hour and its concentration Ca1 is equal to 2 kilomole per meter cube. For a recycle ratio R is equal to 0, the conversion of A at location 2 with respect to the fresh feed at location 1 is 50%. For R tends to infinity, the corresponding conversion of A is dash percent rounded off to 1 decimal place. So this is a question from Chemical Reaction Engineering and the reference NPTEL lecture can be found in Module 1, Lecture 29, Recycle Reactors, Chemical Reaction Engineering 1, Homogeneous Reactors by Professor K. Krishnaya, Department of Chemical Engineering, IIT Madras. So, in this question, let us write down the given data. So, given it is a recycle reactor with volume 1 meter cube and there are two cases. The first case is R is equal to 0 with conversion 50% or 0.5 and the second case is R is equal to infinity for which we need to find the conversion. So the reaction given here is 2A gives B, which is an elementary liquid phase reaction. So that means the rate of this reaction can be written as minus Ra is equal to K Ca square because this reaction can be considered a second order reaction. So when it comes to recycle reactors, a recycle reactor with no recycle or R is equal to 0 can be considered as an ideal plug flow reactor or ideal PFR. And on the other hand, a recycle reactor with R tending to infinity can be considered as an ideal continuous stirred tank reactor or ideal CSTR. So that is one thing we need to remember here when it comes to recycle reactors. And here in this question they have given the both these cases here with conversion 50% for R is equal to 0 or the ideal PFR case, and they have asked us to find R the conversion at R tending to infinity or the conversion at the ideal CSTR case. So for ideal PFR or ideal CSTR, we can write the design equation as tau is equal to V by nu 0, which will be Ca0 minus Ca by minus Ra. So V is 1 and nu 0 is 10, which is given in the question. So 1 by 10 is equal to Ca0 minus Ca by K Ca square because this is a second order reaction. So just expand on this equation. We can write K Ca square as K Ca0 square into 1 minus Xa the whole square. So we can write Ca is equal to Ca0 into 1 minus Xa, and by rearranging this equation we can write Ca0 minus Ca is equal to Ca0 Xa. So just substitute this here. 1 by 10 is equal to Ca0 Xa by K Ca0 square into 1 minus Xa the whole square. So given Ca0 is equal to, so given here Ca0 is given as Ca1, there's just a change in the notation here. So Ca0 can be taken as 2 kilomole per meter cube. And the initial flow rate nu 0 again is given as nu 1 here, which is 10 meter cube per hour. So we have the value for Ca0 and Xa and V and nu 0, and only K here is unknown. So here, to find the conversion, we need to first find the value of K, or the rea reaction rate constant. So we try to find this K by using R is equal to 0 case, or the ideal PFR case. So basically what we are doing here is, here in this question, reaction rate constant K and the conversion XA is unknown. So there are two unknowns, and we try to find one of these unknowns by using the other case, which is at recycle is equal to 0, or the ideal PFR case. So for ideal PFR, tau is equal to V by nu 0 is equal to integral of minus dCA by minus RA from CA0 to CA, which is equal to Ca0 into integral of dxa by minus Ra from 0 to xa. So here also V is 1, nu 0 is 10 given in the question, is equal to Ca0 into integral of dxa by k Ca0 square into 1 minus xa the whole square. So given Ca0 is 2 and xa is 50% for ideal PFR. So xa is 0.5. So just substitute the values for Ca0 and integrate this equation for Xa, and we can find the only remaining unknown, which is K here. And this K, once we find it out from this PFR case, we substitute this K in the ideal CSTR case and find the conversion for ideal CSTR case. So that is the plan here. So 1 by 10 is equal to Ca0, which is 2, is into integral of 0 to xa, which is 0 to 0.5 dxa by k into 2 square into 1 minus xa the whole square. Now all we have to do is just expand upon this equation and try to simplify this equation and solve this equation to find the unknown, which is k. So k will be 2 by 4 into 10 by 1 integral of 0 to 0.5 dxa by 1 minus xa the whole square. So integrating this, we'll get the final answer for k as 5 into 0.5 by 1 minus 0.5, and that will be 5. So the reaction rate constant for this reaction K is equal to 5. So substitute this K in the ideal CSTR case. So for CSTR, we had 1 by 10 is equal to Ca0 into Xa by K Ca0 square into 1 minus Xa the whole square. So Ca0 is 2, Xa is what we need to find, and K we just found out as 5. Now all we have to do is substitute the values for Ca0 and K in this equation, and we will get a quadratic equation. So the final equation we get is 1 minus Xa the whole square is equal to Xa, and rearranging this, we'll get the quadratic equation as 1 minus 3Xa plus Xa square is equal to 0. So the quadratic equation 1 minus 3Xa plus Xa square is equal to 0. We can solve for Xa using minus b plus or minus root of b square minus 4ac by 2a, which is the solution for a quadratic equation. So substituting, we'll get xa is equal to 3 plus or minus root of 3 square minus 4 by 2, which means 3 plus or minus root of 5 by 2. So that means there are two solutions here for xa. So one solution xa will be greater than 1, the other solution xa will be less than 1. We take xa, the solution xa less than 1, because xa, the maximum value of xa or the maximum value of conversion is only 100%. So xa cannot be greater than 1. So whatever value or we found for the solution which is less than 1, we'll take it as the final answer. So this value xa comes out to be approximately 0.382. So that means the conversion here is 38.2%. So this is the conversion for recycle reactor at R tends to infinity. And this conversion comes out to be approximately 38.2%. Thank you.